Say it louder.
Is an angle formed by a horizontal line and an observer's line of sight to an object above the horizontal line.
What the heck's that mean? So if you think about the angle of elevation or the angle of depression, we would have a very good example of this if we would turn around and look out the window and somebody was down in the, what do you want to call it, quad or whatever down there? Okay, parking lot, but even closer up, however close they are, but we're looking down, or they would be looking up to us, right? So which one's the angle of elevation? Them looking up to us, right? So it's essentially the same angle, it's just whatever perspective you're actually talking about, right? So when you do these problems right here, you gotta be an artist today, okay? So you're gonna draw a lot of things. Now, some of you are going to take extra amount of time. I have some people in mind already that will spend more time on your art than you will on the math. Don't try to do that. Yeah? So, this is my art right here. Here's my guy. Okay? And so, if this is my guy and he's looking at his damsel in distress up here in the tower, right? My angle of elevation is the eyesight from me to her, right? So my angle is which angle? It's this angle right here, right? And so then we could figure out this distance right here, right? Between whatever we're talking about, the edge of our building, or like I said, a staircase, or whatever it happens to be, to the person. So again, we could figure out, and we could say that this is maybe X. And then we could really figure out what this is too, right? So between this spot right here, which let's just call Y for instance, and then this degree amount we'll call Z, we should have one of those, or sorry, two of those three things. Most of the time they're not going to give you this slanted side, meaning you won't have to work with it. So if we're working with these three, I guess, numbers, meaning lengths and then an angle, what trigonometric function would we use from yesterday? We're going to use tangent. So you're predominantly going to use tangent today. Okay? Right, so you have to assume, even if they don't really say, that if your building and the distance or the sidewalk, whatever it happens to be, is going to set a right angle. Okay? So even if they don't say it. So, read your definition again.
An angle formed by a horizontal line.
Okay, so where's that horizontal line? The horizontal line is right here. Now continue.
And the observer's line of sight.
Right there is the dashed line.
To an object above the horizontal line. That's it.
That's it. Make sense now? So the words to me don't really make sense, but this makes sense.
So if you ask us what that means as a definition of test, we can draw that.
Absolutely. Absolutely. So what's the angle of depression? So this right here would be considered my angle of what? Elevation.
Down. I know, that's what the other one probably means, right?
So what's the angle of depression? Go ahead.
Angle formed by a horizontal line in the observer's line of sight to an object below the horizontal line.
Okay, now this is the confusing part sometimes. Alright, so we still got to have another horizontal line. So essentially, if I draw this horizontal line this way now, okay, and then I finish my thing, what did I make? A rectangle, not a square. Why isn't it a square? Not all sides. So basically what they're saying is, and this is where it kind of hurts some people, or it confuses some people, they're actually talking about this angle right here as being your angle of depression. So again, when they talk about an angle of depression, you're going to draw this exact same thing, but basically it's this angle up here. But if you think about a rectangle and this dashed line through that rectangle, the dashed line of that rectangle would actually act as the what? Yes, it's a diagonal, but go way back. No? What's true about the top and the bottom? What else?
So you do alternate interiors.
Because these two, this side right up here and this side right here would be what to each other? They're parallel to each other. So this right here it actually acts as my what? Transversal. Okay? And so if this is a transversal, this angle up here that we had and this angle right down here are what? Because of alternate interior angles. So even when they say the angle of depression today, you're essentially drawing the same thing and it turns out to be in the exact same problem.
So your elevation depression is same.
Yeah, because you really think about it. If I'm looking down there, Jackson's down on the sidewalk stretching out or something at track practice, and I yell down at him to come and do some math, he's looking up and I'm looking down, but we're looking at the same angle, right? And so when I'm on one side of it, I can just flip it over because it's really the alternate interior angle. Make sense? That's the hardest thing to grasp. So when they start talking about depression, you'll see it up here a lot, but realistically it's just down there. Okay, so again, draw some pictures, and then you just gotta fill in things. Again, your picture doesn't have to be dynamic.
So the angle of elevation.
The angle of elevation is actually the same.
So, but like, would the angle of depression be like the opposite? Like
Right, it's actually this angle right up here, but they're essentially
so
the same
it
thing.
makes like a 90-degree angle. So if
Kind
one
of.
is like 30 degrees with
No, they're gonna be the same thing.
oh.
They're gonna be even because of this transversal. So this side right here and this side right here are actually the exact same thing. Okay? Your 90-degree thing, yeah, it's gonna form a 90-degree, but those two don't form a 90-degree together. That's it. Here we go.
Sir.
All right, at the circus. It's a good one for you, right? That's a good one for you. This really fits a lot in this group, right? At a circus, a person in the audience at ground level watches the high wire routine. Okay, as you're reading this, or I'm reading this out loud, try to draw a picture on your piece of paper. Okay? At the circus, a person in the audience at ground level watches the high wire routine. A 5-foot 6-inch tall acrobat is standing on a platform that is 25 feet off of the ground. How far is the audience member from the base of the platform if the angle of the elevation from the audience member's line of sight to the top of the acrobat is 27 degrees? So, try to draw that figure. Doesn't have to be pretty. Just draw the figure. This is where the hardness gets to. Okay? Because if I can't draw the figure, I can't do the math, right?
I need help.
Okay, so where's your 27 degree angle? All right, now here's the other thing that's key to this. What else is important to this? Okay, so here we go. I don't want to show you theirs because theirs is outstanding. So, obviously, I'm going to start out most of these problems just like this. I never really care what it looks like, right? Everybody okay with that? Okay, so at the circus, a person in the audience at ground level. So my guy is down over here, or lady, or whoever. Okay, at ground level. Okay? And then it says that some little acrobat guy, lady, is right up here. And so here's my acrobat lady, guy, whatever. Whee! Okay? Is standing on a platform that is 25 feet off the ground. Where's 25 go? Everybody okay with that? Okay. How far is the audience member from the base of the platform? Where does his X go? On the bottom. So X should be down here, right? If the angle of elevation from the audience member's line of sight, so I'm starting at my eyes down here, to the top of the acrobat. is 27. So where's 27? Should be down here. Now, how'd you do? Now wait, I know what you're going to ask, and hold on, okay? What's the most important part of this?
The acrobat's height added on.
Exactly right. You have to make sure that you add the height of the person to the height of the platform. So you got to read the question carefully. Does it say to the height of the platform, or does it say to the height of the person? You understand what I'm saying? Now, here's the other thing that's really, really important in this. Notice what my 25 is labeled as. Feet. What is my person labeled as? Feet and inches. So you really want to say, instead of 5 feet 6 inches, you probably just want to say what? 5.5 feet. Okay? Or make them, but you want it to all be in the same thing. That's what I'm saying, right? So what's my problem?
How far is that?
I know, but what's my problem? I'm going to write. So the tangent of 27. Remember, the angle always goes with the word. And then tangent is what?
It should be 30.5 divided by tangent 27.
30.5. Perfect.
Don't skip
Over
X. Tangent 27.
x.
No, I know that.
So, remember when we have the variable on the bottom, all we have to do is what? The old switcheroo, right? So essentially we're doing 30.5 divided by the tangent of 27. Punch it into your calculator and we get how much? 59.86. Everybody agree? So, now I realize mine's very good, my drawing. So, I really don't want to show the computers because, I kind of showed them up.
Can we do one more?
There's theirs.
That's terrible.
Look at her just, oh yeah.
So X would be
She looks very feminine.
So this
59, I think somebody said?
59.
Yes. So my answer is right here. 59.9 what? Feet. Don't forget a label.
One more?
Alright? Somebody said we need to do another one?
Yes.
Here we go.
Let's go.
At a diving competition, a 6-foot tall diver stands atop a 30-foot platform. The front of the, okay, this is an important one too. Okay? The front edge of the platform projects 5 feet beyond the edge of the pool. So do you understand what that means? So when my platform goes up, they're saying that the diving board comes out this way. Right? So here's the edge that they're talking about, but basically, if we're going to talk about this distance here, we're actually going to what? Probably subtract. Because they're going to probably tell me the whole distance, but my diving board extends out into that distance. Does that make sense? Okay? The pool itself is 50 feet in length. So, again, they don't have a cool drawing this time. So, here's my drawing. And then here's my diving board or whatever. The front edge of the platform projects 5 feet. So this is 5 feet right here. This whole thing down here was 50. Okay? And then we had a platform of 32 feet. And we had a 6-foot dude over here. Or dudette. Dudette.
Is he always going to be on the end?
I don't know, Gabriel. Sometimes not. Depends if he's ready to dive or not. So a camera is set up down here. So here's my little camera. Okay? At the pool's edge, if the camera is angled so that its line of sight extends to the top of the diver's head, again important, right? What is the camera's angle of elevation? So they're actually asking you for this. So now, what is my problem? Tangent of theta, x, whatever you want to put in there, right? So again, automatically, as you write that part, what should pop into your head?
Now you have to add the 5 feet.
No, I got to do tangent -1. Tangent -1 because I'm looking for an angle.
I know that.
Okay? Equals. Bless you. What is my opposite?
33.
38, right? Because we got to do what?
You just shook me off and I said 38.
No, I heard 32. So.
Wait, what's?
38, because why?
32
32 plus my 6 foot tall dude or dudette.
Oh.
Now, what's my bottom side? 45. Why 45?
Because it's 5.
Because my platform extends out into the pool. Okay? So we're doing 38 divided by 45, and then hit tangent of 1 of that, or just do tangent -1 of, and then put that in parentheses. 38 divided by 45.
40.2.
Now again, they say nearest degree, we're going to put a decimal to it.
40.2, you said?
Okay.
40.2 degrees.
So we would say what for this multiple choice problem?
40.
40, right?
40, see.
Everybody good with that?
Yes, sir.
Pretty cool though, right? Now how many are you, next time you guys are watching the circus, you're going to be thinking about this, I guarantee you. No, I'm pretty sure you will.
No, because Dave's gonna be the one who's
I'll
actually on the
just keep cheering
platform,
on
that's
Dave.
why.
Yeah.
Like, look at that funny little clown.
Look at that clown that has stuff.
Here we go, new one. Vernon's on the top deck of a cruise ship and observes 2 dolphins following each other directly away from the ship in a straight line. Now, what they said and how they drew it are 2 totally different things, right? To me, but whatever.
Yeah.
Vernon's position is 154 meters above sea level, and the angles of depression to the 2 dolphins are 35 degrees and 36 degrees. It says find the distance between the 2 dolphins. Okay?
It's fine, this little thing.
Find the x of both the lines.
And then do what?
Subtract them.
Is that J?
So basically, we're doing the exact same problem just 2 times in this problem. And then we would switch the degrees, right? So we're gonna, and again, remember, see how we're looking at the angle of elevation, so this one's down here and this one's down here, really, right? So that's okay. Alright, so when you do this, my 154s are always going to be used, and then we're going to find the bottom part this time. Meaning the distance from, what is it, L there to the dolphin. And then L to the second dolphin. And then you subtract those 2. Okay? You need to do, or see all the math. Okay? So basically this is this one. So I'm doing tangent of 35, 154 over, and then I'm going to do, so I get a distance. Then I'm going to do the exact same thing, but I just change the first degree to 36 degrees, and I get another distance. And then I take those 2 and subtract them apart. Pretty cool, right?
I just like the picture.
Absolutely.
The picture was
Having
cool.
fun.
The picture was cool.
Okay, cool, man.
The picture was cooler.
Can you go back to slide 20? Go back to the first one of the adult shows.
Everybody okay with that? So again, remember, when our variable's on the bottom, we're just doing the old switcheroo, and then we're just doing our math. Okay, so again, this would be where you have to. Did you notice the first thing that I had on the written notes? Do not round until the very end. That's important. Okay? Questions here? Everybody turn your book to page 585 then, please. Greg, turn it back this way, please. We're looking at number 9. Yes, number 9. 584. 584, number 9. Read it out loud. This one's kind of complicated. You got to use this, whatever, how we're going to show you to solve this, it works for number 8 today. Okay? So remember that. Somebody read it out loud, please.
Austin is standing on the high dive after the tree. 2 of his friends are in the water as shown. If the angle of depression to one of his friends is 40 degrees and 30 degrees to his other friend, who is 5 feet beyond the first? How tall is the platform?
Why is this problem hard?
He's
They don't give you the whole distance.
They don't give you what?
The whole distance from the spot
form to the people.
Okay?
We don't know.
So realistically,
We don't know.
Or how tall.
they don't give two different things, right? So this was the shape they made. Okay. Obviously, my pool's not gonna be the same, but we need to know that we have this, and then we got a person on the edge here. And he's looking here and there, right? Quick one. X is over here, and 5 feet over here.
Yep, and what did you say?
And we're looking for what? 40 here,
40 is the lowest one, 30.
and 30 here. Okay? So what are we looking for? What else?
I was trying to find the whole, like, this one.
Right, so we don't really have what? So realistically, do you all realize that we're bringing this over here, right? We can do that, and this is still X? Everybody good with that? Because it's a rectangle again. So if this is X, I can just bring it over here, it's still the same height. Okay? So basically, I'm actually trying to find Y here too, because I don't know that distance. Alright? So this problem is actually pretty hard. So if I'm going to do this, what relationship do these three things have? We're still going to say tangent, and tangent of what? 40 degrees is equal to what? X over Y. Everybody good with that? Okay? And then the next one, so basically now I'm erasing this line right here, and I would do what? Tangent of 30 is equal to X over Now I have to have Y plus 5. Everybody okay with that? Everybody good with how we set those up? Now here's the hard part. How the heck do you solve this? Well, if I'm going to do this problem right here, normally the easiest way for me to do this is to eliminate my fraction by multiplying both sides of each problem by their own denominator. So I multiply both sides by y. These two y's cancel out and I get y out here. Everybody agree with that? So I'd have y tangent of 40 is equal to x. Everybody good with that? Okay? If I do the same thing over here, I get y plus 5 in parentheses times the tangent of 30 is equal to x. Now what do you notice? They're both equal to x. So now I can say the y times the tangent of 40 is equal to, over here, if I have a set of parentheses, what should I do to the tangent of 30 to get it to everything in there? I'm going to distribute. So I'm going to distribute this, and I'm going to take it times that y and times this 5. So I get y times the tangent of 30 plus 5 times the tangent of 30. Would you agree with that? Sure. Okay, all I did was distribute there. Okay? And now, basically, I'm going to bring my y's together. So I'm going to rewrite y tangent of 40, and I'm going to bring this tangent to this side. So what do I have to do to this part? I'm going to subtract that. Now again, honestly, this is probably a little above our pay grade right now. Or, it's not like above our pay grade, but it's just more complicated than what we're used to. How do I get y out of there?
Divide by tangent 10.
No, I'm going to take y out. I'm going to undistribute, basically. When I undistribute, I get y tangent of 40 minus the tangent of 30 inside there. See what I just did there? I'm basically taking a common term out. I'm taking a y out of both of those things.
Now, why couldn't you just keep my terms? Why can't you do y tangent 40 times y tangent 30?
Because they're not the exact same thing. And that's what I'm going to do right down here. So it's like saying 4x plus 8x. And I'm taking out 4x from both, and what's left over? 1 plus 2. I'm undistributed right there. Okay? And so then, now I'm ready to solve. And basically, then I would say, I'm going to have y is equal to, and I'm going to divide 5 tangent of 30 divided by everything in here. Now you can punch this into your calculator.
I don't get why they use this problem.
You don't understand why?
I don't get why they use this problem.
Because basically they want you to do algebra. For real. So then basically you're gonna punch that into your calculator to find what y is. And then once I find out what y is, I'm gonna bring it back to this, probably this original problem. Tangent of 40 is equal to x over y. So when I find this answer right here, whatever that answer is, and I believe it's 11 point something. Yeah, this is 11 point, so this is 11.02 something. Whenever I do this, then I'm just gonna multiply those together to get my x. So basically, it's not as complicated as you really think it is when you look at it. It's just a lot of things that you're not used to doing with the things that you can do. You're more than capable of doing all of that. You just don't think so because you look at it and see tangent and you see a bunch of things that you haven't worked with for a long time. Okay? So again, when you're going through number 8, either take a picture of this or copy that down because that's what you're going to do for number 8 too.
So for the bottom one, where it's 5 tangent 30 over tangent 40 minus tangent 30, why
Yes.
didn't you just subtract the tangent 30 from the tangent 40?
Just
Tangent 10.
Not that one.
That's like saying, can I take the square root of 7 minus the square root of 5 and just take 7 minus 5 and then take the square root of 2?
Okay.
See what I'm saying?
So what would you do after you find out it's 5
That goes into this equation, so this answer right here goes into this equation.
So I go 5 tangent 30, into my calculator, 5 tangent 30 over tangent 40 minus tangent 40. And which is
Basically, I'm probably going to punch this into my calculator first and get a decimal.
But it equals 11.02, right?
The whole thing, this whole thing equals 11.2. And then I'm going to do this problem which we did yesterday.
Tangent 40 times 1.2.
So in all honesty, it's kind of an interesting problem. You only have one of those, okay? I want you to actually try it.
Can I get extra credit?
Then take out number 10.
Let's go.
You don't have to do number 10 then. They're both the same. So you just have to try it one time with number 8. Again now, like I said, it's not as complicated as you might think it is. Did you get the assignment? Take out 10, yes. That's fine.